Let's do a couple of examples of solving radical equations. The method we're going to use has 3 steps. So we're given a radical equation. The first step is to remove all radicals in the equation. Our second step is to solve the resulting equation from step 1. And our third step is to check each of the solutions obtained in the second step to see if they are actual solutions of the original given radical equation. In this presentation, we're going to solve examples 5 and 6 from this set of examples. So let's begin. In number 5, we want to solve the square root of x plus 3 minus the square root of 3x minus 2 equal to 1. So our first step, we want to get rid of all radicals in this equation. So here's how we do it. We're going to isolate one radical at a time, raise both sides to a suitable power to get rid of the radical, and then if we see radicals, repeat the process. Now, let me do it right now. Let me isolate the square root of x plus 3. So I would have to add the square root of 3x minus 2 on both sides. Here is what we obtain. That the square root of x plus 3 equals to 1 plus the square root of 3x minus 2. Now, we're going to raise both sides to the second power, because that is how we are going to get rid of the square root. So square on the left side and square on the right side. On the left side, the square root squared cancel each other, and we obtained the radicand, x plus 3. On the right side, we are squaring a binomial, so we can multiply this explicitly by using distribution. So we get the square root of 1 plus the square root of 3x minus 2 times 1 plus the square root of 3x minus 2. So let's distribute term by term. 1 times 1 is 1 plus 1 times the square root of 3x minus 2, which is the square root of 3x minus 2. Now I distribute the second term. I'm multiplying the square root of 3x minus 2 times 1. That gives me the square root of 3x minus 2. And then plus the square root of 3x minus 2 times the square root of 3x minus 2, which is the square root of 3x minus 2 squared. Now let's clean up a little bit. Observe that the square root of 3x minus 2 squared, the square root and the square cancel, so we're left with 3x minus 2. Here we have like terms. The square root of 3x minus 2 plus the square root of 3x minus 2 is 2 the square root of 3x minus 2. Observe that we have like terms here, 1 minus 2. 1 minus 2 is simply a negative 1. So let's write negative 1. minus 1. Okay, we have a radical. We still have radicals in our equation, so we're going to repeat the process. We're going to isolate this radical now and then raise both sides to the second power to get rid of it. Now, to isolate the radical now, let me get rid of the 3x minus 1. To get rid of the 3x, I subtract 3x on both sides. To get rid of the minus 1, I add 1 on both sides. Cancel. X minus 3x is minus 2x. 3 plus 1 is 4. Now, if we want to strictly isolate the radical, we should divide by 2. Although, if we don't divide by 2, we could still get rid of the radical by squaring both sides. But in this problem, if we divide by 2, we make the equation simpler. So let's do it. Let's divide both sides by 2. Right hand side divide by 2. Left hand side divide by 2. Observe that there is cancellation. The 2's cancel. So we're left with negative x. The 4 over 2 becomes 2. So that's plus 2 equals. The 2's cancel. So we obtain the square root of 3x minus 2. Now we square both sides to get rid of this last radical. So on the right, the radicals cancel. The radical and the square cancel, so we obtain 3x minus 2. On the left side, we are squaring a binomial. So the result from that will be, after we do the algebra, will be x squared minus 4x plus 4. Okay, now we go on to the next step, our second step. Our second step is to solve the resulting equation. This is a quadratic equation. Let's solve that quadratic equation now. So let's do it here in the middle. I'm going to keep the original equation. So I'm going to erase the middle. So, since we want to solve this quadratic equation, we should make one side a 0. So let's make the right side 0. To get rid of the 3x, subtract 3x on both sides. To get rid of the minus 2, add 2 on both sides. So we obtain x squared minus 7x plus 6 equals 0. Now, to solve this quadratic equation, we can factor. We can use the factoring method because the polynomial factors. X squared minus 7x plus 6 factors into x minus 1 times x minus 6. So two solutions come out of this. X equals 1 and x equals 6. Now on to our last step. We're going to check to see whether 1 is an actual solution of our original equation, and the same thing for 6. We're going to check to see if 6 is an actual solution of our original equation. In other words, we're going to check. Okay, so let's check x equal to 1. We're going to plug in x equals 1 into our original equation to see if it satisfies that equation. So check x equals 1. Now, when I plug in x equals 1 in my left hand side, I obtain the square root of 1 plus 3 minus the square root of 3 times 1 minus 2, which happens to be equal to the square root of 4 minus the square root of 1. 3 times 1 is 3, minus 2 is 1. So the square root of 1. The square root of 4 is 2, minus the square root of 1 is 1. The result is 1. So when x equals 1, my left hand side is 1. Observe that that is the same as the right hand side. In this case, we conclude that x equals 1 is an actual solution of our equation. So let's write it here. X equals 1 is a solution. The solution of our given equation. Okay, let's check now x equals 6. So let's make this space here to do that second check. So check x equals 6. When we plug in x equals 6 in our left hand side, we obtain the square root of 6 plus 3 minus the square root of 3 times 6 minus 2 which equals the square root of 9 minus the square root of 16. Observe, 3 times 6 is 18 minus 2, 16, which is equal to 3, the square root of 9 is 3, minus the square root of 16, which is 4, and the answer to that is -1. So my left hand, when x equals 6, my left hand side is -1. Notice that my right hand side is 1. So in this case, the left hand side and the right hand side are not equal. I conclude that x equals 6 cannot be a solution of my given equation. So here, x equals 6 is not a solution. So I must reject it. The only solution that we get for our equation is x equals 1. Okay, let's try our second example.